In this lesson sequence, we learn how a passive solar building uses only the sun to keep warm in the winter and cool in the summer. We'll discover this phenomenon that the energy required to heat a home can actually be 50 to 70% less in a so-called passive solar home compared to a regular home. In 2.13, we look at the unit roadmap. Why is the roof asymmetric? By the end of this sequence of lessons, our students will get it. Students pass around a chain note to write down everything they know about energy and homes, and we need to prompt them to remember the questions we always ask for the energy cross-cutting concept. Where does the energy come from? Where does it go next? And does it change forms? Students then build on those ideas to brainstorm ways that they could design a home that stays warmer in the winter and colder in the summer. In 2.14, we begin with a short interactive presentation where students analyze the difference in energy use between a passive solar home and a regular home. They look for patterns in images of actual passive solar homes. Students then watch video tours of different passive solar homes that describe the building design and the materials that are used. Students then draw models illustrating how energy enters a passive solar home and how that works differently in the winter versus the summer. And at the end of the class, we revisit the phenomenon. And I think we can now explain a little bit more about how passive solar homes use less energy. While using the sun to stay warm on a winter day is easy to grasp, passive solar homes also rely on something called thermal mass that's a little bit more complicated. We'll use this phenomenon in the next sequence of lessons to discover that concept, that sand heats up and cools off faster than water. In 2.15, we introduce the hot and cold sand phenomenon. Students then use an online simulation to investigate how different substances heat up differently, and then they explain those differences using a model of moving molecules. Some materials heat up faster because they have less thermal mass to heat. Students then design their own investigation to test a single material to see how much thermal mass it has and if it would be a good one to use for a passive solar home. The exit ticket checks to see if students can explain how thermal mass helps passive solar homes save energy. But which material should we use in passive solar homes? Students expand on their investigation from yesterday to test how different materials heat up. But they start with an interactive presentation to make sure that they can answer, how do we plan a good scientific investigation? Then students decide which materials they want to test. They spend the remainder of the class writing out the steps of their procedure to ensure that they have a fair test. Students begin the next class by revisiting the exit ticket from lesson 2.15. We want to make sure that students can articulate how all three of these ideas relate: thermal mass, passive homes, and climate change. And a worksheet then guides students through carrying out their investigations, collecting data, and reflecting on their findings. They'll have a fair test to figure out which materials are going to be best for a passive solar home. In 2.18, we tie up this section. We finish our thermal mass investigation worksheet from yesterday. We revisit the hot and cold sand phenomenon, and check in about students' progress on their energy reduction action plans. Do they think they're saving energy? Next up, we'll add more pieces to our conceptual model of passive solar homes, and then design and test some real-life physical models.